Welcome to the Building in Decentraland video series. These videos are recordings of the live sessions of the inaugural class offered by the VR Academy, which is a school within Decentraland University. My name is Carl Fravel, and I'm the instructor of this course. These videos are largely unedited recordings of the live class sessions. The descriptive text provided below this video includes information about Decentraland, a virtual reality on the blockchain, the Decentraland University and its schools, including the VR Academy, and the course materials for this course, including the lessons and assignments. I hope that you enjoy studying these materials and that they help you to become a very capable builder in Decentraland. So, can you hear me okay? I'm on a little different connection today.
I hear you well.
Okay.
It's Mike. Hi. By the way,
Mike.
everyone who clicked on the link I provided in university is now me. So I feel a bit like in this movie Malkovich. There are lots of my questions there. But please use the link. Please use the link from your email.
Okay. There were a lot of questions from lesson 2 from people who are not familiar with either the operating on the command line or installing utility programs or using Typescript. I just want to review some things before we start on the new lesson. I don't want people to fall behind. The 2 hardest things we're doing in this course for people who don't already know them is programming, Typescript, and using Blender. And this course is going to be kind of cumulative in what you learn and how you apply it. So again, I don't want people to fall behind. So I want to spend a little time reviewing. And I had some notes on what I was going to review today. Hold on. Just remember that I put them. Greetings. Okay, so I want to, first of all, look, somebody has their open air open. Please mute your microphone if you're not talking, and or put on headphones, or both. Thank you. Yeah, that's much better. So the first thing I want to do is I just want to review a little bit about using the command prompt window. And it's called Terminal on Mac and Linux. In Windows, it's called Command Prompt or CMD. You started in Windows by opening up the Start menu. And oh, I haven't shared my screen yet, have I? Let me do that. Sorry. Share screen. That would make it better, easier to tell what I'm doing. Can you see my screen?
No.
All right. Thank you. Please mute if you're not talking now. Thank you. So in Windows, you go to the Start menu down here in the lower left, and you type CMD, and you'll see this black command prompt window. You pick that, and that is the command prompt. It's the Windows equivalent of Terminal. Terminal is what you have in Mac or Linux. And there's a few commands that the terminal window knows. I often have it kind of small, but you can make it full size. If you type help, you get all the various commands, and they're listed as though they're in uppercase. They don't have to be typed in uppercase. One that you use a lot is CD for changing directories. That's how you get up and down in the directory hierarchy. Another one you'll use is make directory, mkdir. These commands are essentially the same or identical in Linux. You may end up using a remove directory sometimes. But let me just show you a little bit of that in the command prompt window. So When you open up a terminal or command prompt, you are in your home directory. And on Windows, whoever is speaking, can you please mute? Thank you. When you open up terminal in Mac or Unix, you'll be in what's called the home directory. And in Windows, it's called your user directory. It's C:users and then your user ID for your computer. If you just type CD, it actually prints out what directory you're in. In Mac or Windows, it would be PWD, present working directory. And then to see what's in a directory, you can do Windows, you do a dir directory, and you see directories, subdirectories, and you see files. And if you are on Mac or Windows, you'd use the ls command, like ls and maybe -lt to get some details. And you'll get a similar view. I want to make sure everybody understands that this is very similar to what you see in Windows Explorer, which is, this program here, right? That you use in Windows frequently to get around. And here is my home directory in Windows. It's the same folders as are listed here when I did a directory. And the equivalent of saying, hey, I want to go down into my WebVR directory and into my Decentraland directory and various scene directories would be in the command line, it would be CD. I don't need it to be capitalized, CD. And on Windows, you can type, start to type the directory and then hit a tab key and it fills in the rest. And in Windows, you have to use backslashes between the directories, whereas in Linux and Windows, Mac, you'd use /. So if I type D, I have a DCL directory. And in here, I have the same directories that you see if you come over here into that WebVR DCL directory. So these two views are two different views of the same thing, which is the directory structure or folder structure on your computer. And when you're working with SDK, you'll be going back and forth between them. So I wanted to show you how to quickly you're in a directory that you've gotten to in the command line, and you can say Explorer. In Windows, you can do this. I think in Mac, you say open and open dot, and it opens up Explorer on that directory. And similarly, if you're in, let me do that again. If you're in a directory, let's say I want to go down into the Etheria district into a scene here, and I want to open this up in the Explorer in the terminal. I can click up here, copy this path into my clipboard, go back into here and say CD space, and then Control V to paste that in, and now I'm in that directory there. So those are just some shortcuts and hints for jumping around between the two views. The command line view is what you will have to use to install the SDK and to use the SDK commands. You would do it from this command line. But if you're like moving files around or looking to see what you have, like what models do I have in here, then you probably will want to use your Explorer or Finder. Does anybody have any questions about any of that so far?
No.
Okay, now I want to show you an example of a folder structure. I put some images of this in the tips and hints at the end of the lesson. I've added some things there based on questions that people have had. And this is an example of a folder structure that it's my folder structure off my computer. So let me explain it a little bit. Here's my home directory, user C Fravel. I have done some work in some other WebVRs besides Decentraland in the past, so I already had a WebVR directory. and I put a DCL directory under that. You might just want to put a DCL directory right under your home directory. And then inside here, I have, underneath DCL, I have some kind of categories folders. For example, this one here is where I'm doing scenes for the conference center in Decentraland. So each of these folders is a scene. I have, from the Decentraland sample scenes, I have a couple that I've downloaded and put in here. Under this folder, which is not expanded, I have scenes from District X that I'm helping with. I have a folder for experiments. I just, when I want to try something, I'll put it under here so it doesn't clutter up other things. Clearly, you don't want to run DCL init directly in your home directory, because it's going to put all the files from a scene into your home directory together with everything else, and you won't be able to make a second scene, and you'll have kind of a mess. So use a folder structure. If you have already run DCL init in your home directory, don't worry, you haven't terribly broken anything. And as you get familiar with navigating and using the tools, you can clean that up later. Here is the, what's inside a scene? What's the folders and files inside a scene? So here is a particular scene. It's a meditation garden in the conference center. And I wanted to show you what all you might find in a scene. Some of this is more than what you'll find until you're working with later lessons, because we're going to introduce other tools and methodologies. But I'm just kind of go through them. This first folder, if you see it in a directory, like if I send you one and it's still in there, it's a .git directory. It is an artifact or a side result of using the Git file repository system. We're going to be using GitLab as an example of that later in the course. The bin directory is where the DCL start or the DCL build commands put the results of the build. Excuse me. And generally you don't mess with what's in there, but you won't be able to actually preview a scene until that gets generated when you do DCL start. DCL export command will create this export directory, which is a standalone scene that you can put onto a foreign web server in the cloud, or you can put it into the Zeit Now free server system, which we will talk about later in the course. Materials is a folder that if you have it, you probably have it because you have some materials that you're applying to primitive shapes, like cubes and planes in your scene. And it's not a model, it's just an image file. So rather than putting it under models, typically it's put under materials. Many of these folder names are arbitrary. It's just customary of what they're called. So models is where you would put your 3D models, your GLTF or GLB models. And again, that's a standard practice. Inside your script file, you'll actually use the folder name. So it could be anything. And you can also nest them. But to be consistent with other people's work and for them to understand your scenes, for it to kind of fit with the documentation, you'll find typically models are put under a models directory. Sounds are put under a sounds directory. Materials or image files for putting on the surface of things are put in a materials directory. This particular scene has some animals and some trees and plants, and it has some people, and it has a widget that I use for building. And so there's subdirectories under here, and under each of those you may find, like for example, under Flora I have a tree A folder, and inside there you'll find the GLB file for that tree. So you could put all your GLBs and GLTFs all together in the folders in the models folder, but I would find very soon I'd be confused. Does this image go with that model or with that model, and what is what here? Sometimes the models will have strange names, and so you can use the folder structure if you want to make it a little more clear what something is. Node modules directory is generated by installing the local part of the SDK. That happens when you do a DCL init or an npm I. DCL init is used when you're creating a new working directory in an empty directory. But if you already have content there and it doesn't have the local part of the Decentraland SDK in it because, for example, you got it from a zip file from somebody who omitted all that other junk, npmi will install the local part of the SDK in the current directory. And in doing that, it generates this node modules folder. And if the file isn't already there, it'll generate the package lock.json file also. You don't need to worry about what's in node modules. You just need to have one when you run the scene, if to preview it or to deploy it. If you have sounds in your scene, you could put them in a sounds directory. That would be MP3 files typically, but there's a few different formats that are supported, and they're documented in the Decentraland docs, but typically you probably use an MP3 file. The SRC directory is kind of where most of your attention is going to be because the file in it called game.ts is the main definition of what your scene does and has in it. DCL init creates a default boilerplate copy of game.ts that has some clickable rotating cube demo, which we will use in a little later part of this review. Game.ts can refer to other Typescript files. Sometimes you want to put some code into a separate file because you're going to use it in various scenes. You want to just have one version of that and copy it into your various scenes and then refer to it from game.ts. That's called importing a module. And so there's a module subdirectory in this scene that has 3 other Typescript files in them. .dcl ignore. Dot tends to make, at the beginning of a file name, tends to make that file invisible to directory looks in some cases. A file might be there that you don't know is there because it has a dot in the beginning, but other views will display that those folders or files are there. .dcl ignore is a folder that contains a list of files and folders that you may have in your folder structure but are not part of the runtime of the scene, and you do not want to upload them to the LAN or deploy them when you deploy your scene. So this suppresses DCL, the DCL deploy command from pushing those files up into the LAN storage. For example, you might have a zip file in here. Typically it doesn't belong in here, but let's say you have a good reason to store some stuff in a zip file in here. You would put start.zip into the DCL ignore text file. I have a supplementary document that's linked from the class document about how to use Git and Zeit now, and it gives examples of DCL ignore and Git ignore and some of these other files. So if you get to that point. Decentraland provides a default DCL ignore file when you do DCL init. It's pretty good. It doesn't contain everything that it might to keep stuff from being uploaded to the LAN. I've given them a newer, more complete one, and they like it, and they might substitute that in the future, but you can read about it in that supplementary doc if you're interested. Git ignore is a file that goes with the Git repository system, and it says what things in your file system you don't want to push up into your repository. And examples of that would be the bin file or the export file, which contains the build results. Typically, the only things you put in the Git repository for safekeeping and versioning are the source files, your image files, your game.ts and other TS files, etc. A few of these files in the root directory would be stored too. Deploy.now is a batch file. It's one of several batch files I tend to put in my directories. Batch files are real simple ways in Windows to get things to happen without having to type all the commands yourself. Deploy.now is a batch file that I use to push the contents of the scene up into the Zeit now system just from a single command. Docker file is, I don't know if it's required to run on the thing in the world. It seems to be kind of always present. It's the definition file for a Docker image, and I'm not sure where Docker images are actually being used. I just ignore it. It gets generated. I include it in zip files when I make them, etc. Now.json is a text file that includes the name of this scene as you would want it called in the URL if you upload the scene to the Zeitnout server. Package.json is an important file. It's required. It basically tells the runtime, the build time, excuse me, of the scene what other modules from npm are necessary to operate the scene. And the main thing it says is you have to have the Decentraland SDK, or at least a part of it that lives in the local directory. And so typically you won't be editing this until you're maybe a little bit more advanced. It is how you would control the version of the SDK you're using. So if you want to freeze that while you're doing development so that you're not affected by updates of the SDK while you're working, and then maybe just before you deploy, update it to the most recent one and then check it out, make sure nothing broke or fix anything that broke, and then deploy it. That is a possible strategy. You also can leave this to have an indication you just want to use the latest version all the time. But typically you won't be editing package.json. Package.lock.json is a file that gets generated by the npm system. And I don't know exactly what it does, but it basically provides some information about the versions, again, that should be used. And it gets generated when it's needed. So basically, you're going to leave that one alone, too. I have a couple of other batch files here that, deploy now and prep DCL batch. They just contain a number of different DCL commands or now commands that I would typically have to type them all out one at a time. And instead, I just put them all in a batch file so they all run at once. Examples of those are also in that supplementary document. readme.md is a file that is the typical documentation file in Git repositories. Since I want to document this scene for me and the people testing it as I'm developing it, I'll put some documentation about how the scene works or issues that it has or whatever in. Can you still hear me?
Yes.
Yeah, okay. I'm hearing some sounds. I want to make sure I wasn't losing my my connection. Okay, so that's what readme.md is. Scene.json, a really important file, which you probably won't need to touch early on until you get to the point where you're deploying content to land. Scene.json contains the list of parcels for your scene and where they are in the world, so that when you deploy, you'll be deploying to the right place and to land that you own. If DCL init creates a scene that has one parcel that's at coordinate 0, 0, which is just fine for all your prototyping and learning work. You can even make a scene that's bigger than one parcel without any problems in the SDK right now. But later, if you want to make the gray grid larger to match the size of the scene, you could edit the scene.json file. And I have a tool that makes it a little easier to generate a larger scene in the format of text that has to go in that file. These other two JSON files are the ones that are used when I deploy to land or deploy and export to now. My batch files copy those into scene.json, so that's what that's about. tsconfig.json is another required file that tells the Typescript language how to work. And that's that compiler, the Typescript compiler, is what runs during DCL start or DCL build in order to turn your game.ts and other TS files into a game.js file, JavaScript file in the bin directory. So you won't be able to proceed if you delete that file. You'd have to reestablish it. If you've lost some of the parts of the SDK in a scene that you're working on, you've inadvertently deleted a file, probably the best thing to do is to run npm -i to see if it restores everything that's needed to make it work. The other possibility is go into a new directory, type DCL init, and then copy the critical files over from this directory to the new one. Before I go on, and by the way, the documentation describes these files in detail too. And before I go on, I want to leave it open for any questions. I don't have my chat window open. We'll have some time probably for questions at the end too. So if you end up with a question, feel free to ask along the way, or we'll try to leave some room at the end. The other thing that people asked a lot about was, so I put some other objects into my scene after doing DCL init, and they're all rotating. In fact, I put some grass on the ground and the whole scene is rotating. How do I make that not happen? And so I did some kind of little progressive studies in scenes the last few days. I'm going to walk through a series of scenes, starting with the raw DCL init scene, and kind of talk about what they do and why things happen and what you can do to control that. The link here, and it's also in the Discord, is to the zip file that contains those scenes. I'm going to show you how you would use that zip file. I'm going to download the zip file. I'm opening up the zip file, and I have 5 scenes in it. And I'm going to go to my Windows Explorer and go to my DCL directory. Oh, this is, sorry, a DCL directory. Click here. And I have a directory called class, but I'm going to create a new one called, so you can see the whole process. I'll call it classy. So I'm going into there. This is a subdirectory under my DCL. You call this my home directory, and this is a folder to hold many scenes. And I put a subfolder into there for this group of scenes. And I'm going to take them from my zip file. I did a click and a shift click, drag this over a little bit, and drag these scenes into this folder in which I'm going to be working on these scenes. Pretty typical thing that you do if somebody sends you a zip file with a scene, or if you download one of your fellow students' zip files of the scene, you would take the contents of it and put it in a folder on your machine. And if they've zipped up the file correctly, what you'll find in it is a source directory, perhaps some models and materials and sounds if the scene has some, and the basic required files for the scene. You won't have node modules, which is huge, and you won't have package lock. You won't have the bin directory. You won't have, as I said, the node modules. This scene by itself can't run, but it's everything you need to get going, and it's much more compact. So it's kind of a polite way to deliver it. But you want to have these files and folders in that. I'll just show you the most advanced scene. This scene also has a models directory because the scene has models. So I'm going to go into this first one, and actually I'm going to take that URL and put it into here and go CD to there, and I'm in that folder. in the command line. And the first thing I want to do is install the rest of the SDK, which is far bigger than the scene itself that's in the zip file, but which is why it's nice not to include that. It's not the end of the world if you include it in zip file, it just makes it much bigger. But that little quick operation, and now I have the things that we're missing, node modules in particular, and package lock got generated. And now I can do DCL start. And what we're going to see is the same scene you see when you do DCL init. Recognize the scene, everybody? I think anybody that's done DCL init and then DCL start has seen this rotating cube. And what you know this scene does is if you click on the box, you get another box. And each time you click on that box, the original box gets longer and thinner. And it generates more and more boxes, each of which rotates, and we're positioned in random locations. You can get pretty crazy here. You can get this thing to grow completely out of the scene if you work at it. Look out, you're going to get knocked off the boat. This is a new feature of the SDK that's very recent, is that a moving object with a collider will move you. That was not true a few weeks ago, so they keep making it better. This would actually allow you to make an elevator. Okay, so you understand the scene, and everything in it is rotating. So let's look a little bit at the code for this scene, which I will do by hitting Control C and yes here, back in the server. And I'm going to use the Visual Studio Code application to look at the code, and it's down in the source directory. And in Windows, use a backslash. And hitting G and Tab to get the game.ts to type out. And up at the top here, you see, I wonder if there's a way I can hide this guy. Yeah, I don't see it. Okay. Up at the top, you see a tab for this file that's open, and you can have many tabs open, many files open in code at the same time. This is the DCL init scene, but I've added comments. So I'm just going to walk through some of this code and talk about it. Those of you who know Typescript really well, you can doze if you want, or point out things that I should have been explaining. So I've added these 4 comment lines. This word class is a way of defining a collection of code and data. Here's some data up here at the top. Here's one function or method inside the class. So there's both data and code in here. It's a bundle. You can think of it as a template for something you're going to make one or more copies of.
An object, if you like.
Mm-hmm. Yep. And when you use this, just having this here defines it, but it doesn't actually use it. You use it by doing a new, you say new, and the class name, and a pair of parentheses. And what that does is that creates an instance of this class. Go ahead.
No, just it's the class is like the shape.
Template.
And the instance, yes, the template, and the instance is once you fill it with live, if you want, with data, and then it becomes an instance in your memory. And before it's just an idea.
Yes, an idea. It occupies a little bit of memory as an idea, but it doesn't actually do anything until you instantiate it. You'll hear that word sometimes. You're saying, give me a new one of those things, rotator system. So One of the reasons you would do this is because you want to simplify the appearance of your code. Is that you want to bundle all the stuff that relates to the rotator into one place. And another reason you might do it is later on in your code, you might instantiate a second rotator system using the same class, but have it do something a little different. Another reason you might do this is if you might put this code into a module and have it be actually in a separate file because you want to use it not only in this scene, but in 7 other scenes. So these are reasons why you would use a class. It bundles data and code into one definition and multiple instantiations or uses of it. Let's talk a little bit about what a rotator is. In the Decentraland SDK, something called a system can be added to the engine with a statement like this: engine.add system and an instance of a system. And what that does is it gives it to the runtime engine in the scene and causes the engine to call the update method in the system. So a system has to have an update method, and it calls that update 30 times a second, which is basically like the frame rate of video in the. It's fast enough so that motion looks smooth. And you often use it to move something or rotate something a little bit every 30th of a second, or to test whether something's happened, a certain condition has been met, and you're testing that every 30th of a second. So you can use it for a lot of different kinds of things, but it's something that allows you to have dynamic behavior in the scene because 30 times a second you're being called here and you can do something. In this scene, the update function is being used to rotate the cubes. Let me first talk about this parameter. The required parameter that must be in your update function is a single numeric parameter. Typically it's called DT, and it stands for delay time or delta time. It says what fraction of a second has gone by since the last time this was called. That number is almost always 1/30th of a second, plus or minus a little teeny bit. It happens to be the very first time it gets called, it's close to 0 because it's never been called before. It's just the amount of time since the engine started up. But all the subsequent calls are like 0.03333 seconds. So this is a number that is a floating point number. It has a fraction, and it's the number of seconds or a fraction of a second since the last time that update was called. And it can be used in your calculation if you want to move something or rotate something to use that as a time indication to say how fast to move or rotate something, for example. I have something here that is making all kinds of noise in my computer. Let's see if that stops it. Hopefully you're not hearing all those beeps. Let's talk a little bit what happens in this scene with the calls to this update function. The core of it is that it's going to rotate the box, rotate the cubes. And so that's the line of code that actually causes the thing to rotate. But it's rotating every cube in the scene. So how's it doing that? It's doing that by this for loop. And in the for loop, it's going through every entity that's in this group of entities. And how do they get in there? Well, at the beginning of the rotator system, when the rotator is instantiated, it goes out and says this variable holds a group ID from the engine of everything that's been put into the engine that has a transform component. That's just how this Git component group works. It is documented in the SDK documents, but basically it says, go out and get me all the entities that have a transform. And now I have those as a group, and I can iterate through them with this for loop. Some of you probably have done a little programming in the past where a for group is like let I equals 0 to, it's like based on an index value. TypeScript has that format, but it also has a couple of other formats for loops. And in this syntax where you say of is saying this variable is actually going to hold each of the things from that group as it goes through here. So down in here, we use each one of those as it comes through the entity that you got here from the group, and it gets the transform from it, the transform component that was added to it to give it a position and size and rotation. And then we're going to rotate that transform on that one object. And then I'm going to loop that and do it for all of them. So that's what this code is doing. I want to talk a little bit about this little piece right here that says how much to rotate it. So it says rotate it 10 degrees times 1/30th. So it's like a third of a degree every 30th of a second. 0.0333 times 10 degrees is how much to rotate it each time update is called at 30 times a second. I'm going to pause for a moment. Anybody has any questions about classes, systems, rotation, update method, how iteration is working here?
Maybe just a comment. There's this, I think you mentioned it earlier, that there's this website for TypeScript, and they have really good documentation. So you get lots of examples how you can do these iterators, for loops, and things like that. That's maybe helpful.
Yes, it is an excellent documentation set. So just Google TypeScript and go find the official TypeScript docs. It's probably been mentioned before. If you're familiar with JavaScript, this is going to look pretty familiar because TypeScript is an extension. It's an improvement on, if you might say, JavaScript to make it object-oriented and typed, especially to make it so that if you say in JavaScript a equals 3, a moment later you can say a equals, quote, hello, unquote. And suddenly you've changed the type of what a is, and that can introduce all kinds of bugs in your code. So in TypeScript, a variable takes on a type, and it stays that type. And you can even say, this particular example doesn't have a good example of that, I think. Yes, it does right here. So this variable, in JavaScript, you simply say x comma y comma z. But in TypeScript, you use a colon and a type after the variable or parameter name to say it's a number, it's a string, it's a rotator class, it's whatever. And then that variable will stay that type. And if you assign something of another type to it, it'll throw you an error and tell you your code's not working right. So that's the main advantage of TypeScript, is that it's a safer programming language. It'll tell you that you have something wrong in your code earlier in the life of the code of the development process, like right here in the editor. It'll show you that it's wrong. Let me show you an example of that. So I'm going to up hit the top of the code here. I'm going to say n number equals 3. But I have to put something before it to declare it. I have to say either let or constant. I'm going to use the word let because I'm going to try changing it. And then you can say n equals 4, right? Everything's fine. But if you say n equals hello, you have an error indication. And if you hover over it, it says hello is not assignable to a type of number. You have a little piece of curly red under here. If this was a larger word, it'd be more obvious. And also, right over here on the right, you might see that there's a red dot here in the far right of the UI, and that says sometimes you see lots of dots in your program, and it says you've done something that's broken a lot of the code. So that's a nice thing about TypeScript. It's a little safer programming language, but otherwise very similar to JavaScript. The JavaScript libraries work with it. Anyway, it's a nice programming language. So we talked about this rotator system, how it gets added. I'll go on in the code and talk about a few more things. When you create an entity and give it a shape and a transform and add it to an engine, it takes several lines of code. And when you are doing a lot of, creating a lot of objects in a scene, a lot of entities in a scene, you'd have all these lines of code again and again. And that's what you see in the code that you get from the builder. It's, you see these repetitive patterns of code again and again and again that basically do the same thing with a little variation. One way to simplify your code is to wrap that series of things in a function. A function is purely code, whereas a class is a combination, is a template for both data and code. Function is something that does something, and you're going to call it later in the code. And so this function spawns a cube at a particular location, X, Y, and Z in the scene. So the way it does that is it calls a class in the SDK called entity with a new, so you get a new instance of an entity, and assigns that to a variable arbitrarily named cube. And then it is also adding a component to the cube, which is the transform that controls position, scale, and rotation. And they're only, in this case, defining the position using the X, Y, and Z that came in here from the parameters. So when you call it, you give it the X, Y, and Z of where you want the cube to be. And here's an example of the call right here. So spawn cube is calling this, and they're passing in the X, Y, and Z coordinates of where that cube is going to be. That's the main cube at the beginning of the scene. And then you could, in addition to position, you could also define the scale and the rotation of in the transform. But because we're not defining them, they're the defaults. So the default for position is 0, 0, 0, right at the southwest corner of a scene on the ground. The default for rotation is not rotated, and the default for scale is the default size of that shape. And those 1 times its normal size. And since we're only defining position here, the rotation and scale are the default values. The second thing we're doing to this cube that we created, this cube entity, in addition to adding the transform to it, we're also adding a shape to it. Again, this is a class in the SDK that we didn't have to define. It's predefined for us. We're saying I want a new box shape, and I'll add that component to the cube. So now, whereas up until this point, this entity, what we called a cube, wasn't really a cube yet. It was just an empty point in space that's not visible. It's just a location, rotation, and scale concept. It's an abstraction. But by adding a box shape to it, now it is a box at that position with the rotation and scale of default values. So until you add a box shape or some sort of shape, a GLTF shape, a plane shape, whatever, you don't have a thing, you just have a point in space. Finally, they're adding the, almost finally, to the engine. The engine is the runtime Decentraland displayer, renderer, manager. Actually, the renderer is in your client, so it's not there, but it's the thing that, amongst other things, causes things to be visible in a scene. It is also the thing that causes updates to be called on a system. There's 2 really important calls on it. One is add entity, and the other is add system. So engine.add system, engine.add entity. Finally, by doing that, this cube appears in the world and is rendered. If you don't make this call, even though in memory you have this cubical entity, it doesn't show in the scene until you say add it to the engine, and so it'll get displayed. And now finally, the thing it does is it returns the internal value of cube back out to the caller. The caller is a spawn cube call to the function, and the cube that gets returned here gets placed into this cube variable. Let's talk about scope of variables briefly. This cube here, this variable is only known in the scope of this function, inside it. That's why there's no name conflict between cube here and cube here, because this cube is in the scope of the outer code of the file, and it is a different cube. You notice if I click cube here, Visual Studio is smart enough to light up all of the other uses of cube that are in the same scope, but it doesn't light this one up. It's a completely different variable, even it has the same name, because this is bound within, constrained within the scope of the function. This one down here is a different cube, and this is what's being done with it. The time at which this cube becomes visible in the world is when this line is executed, calling spawn cube. The cube is entity is created, its position, scale, and rotation are created, it's turned into a box shape, and it is added to the engine and displayed. And then it returns here, and it turns the handle to that cube into this variable here. I'm going to stop for a moment and see if there's any questions about any of that.
Hello.
Hello.
Would that be similar to what the builder does with duplicate?
What the builder would do with duplicate would be the equivalent of taking this line of code here, copying it, putting another one here, and renaming the second variable cube1 and moving it somewhere to a different position by changing these numbers. That would be the equivalent in this code of what duplicate in the builder does.
Okay.
I just want to show you an example of some builder code. You probably have all seen it, but you'll see that this pattern here is being done again and again in the code instead of using a spawner function. I guess the quickest way to do that would be to open up a browser and create a new tab here, go to the builder. Can I move this thing without muting or something? There's got to be a way to minimize this little guy. Anybody know? Oh, I could dock it to the bottom so it's out of the way. All right, that's better. Builder.decentraland.org. Here is Rose's scene. I'm going to download it. I'm going to go into the source games file, double click that, and it'll open up in a second tab in code. And the reason I'm getting all these underlines is because I don't have it sitting in a scene that has the SDK present. So these calls out to SDK classes are unreferenced. It doesn't know what to do with that. It's sitting in a zip file and it doesn't have an SDK around it. So that's why they're all red. But if you just look down here, you're going to see this pattern again and again and again of creating a new entity. In the builder, they're setting the parent of the entity to the scene. Creating a shape, adding the shape component to the entity, creating a transform, in this case, position, scale, and rotation, adding the transform to the entity, and adding the entity to the engine. So other than the fact that this is a GLTF shape instead of the cube, and other than the fact that they're explicitly stating what the rotation scale should be, and other than the fact that they're adding it, they're setting its parent explicitly. The other lines in here are pretty much what you see in this code right here, adding a component of the transform, which you created, adding a shape, adding the entity to the engine, initially creating the engine. So these 4 lines of code here are the same as this line here for creating it. Excuse me. I'm going to do it on this one here. Creating the entity, creating the shape, adding the shape to the entity, using add component or replace. It's just a little more general purpose if there was already a component of that type that replaces it instead of causing an error. Creating a transform with these curly braces inside the parentheses with 3 things inside those curly braces, the position, rotation, scale, and adding the transform to the entity and adding the entity to the engine. So this code could be a lot shorter. You know, over here on the right, you get to see a preview of the entire code file. Look, to see all the repeating pattern here again and again and again and again. You could have a single line of code for each one of these and a spawner at the top. This is what they've done in this other scene. So what's unique about this particular object is just this one line right here. I see there's some question about the TypeScript. Okay, is an entry point for it. Thank you, Mike. Any questions about a spawner function or how it simplifies your code? Let me just show you what would happen if I duplicate this line. Control C, Control V a few times, and say, let's put it at 10 and 12. I'm going to have 3 cubes in there, right? I'm getting an error message here. It's a warning because I'm redefining the variable. If I hover over this, it's going to say, can't redeclare the variable cube because you already have it. So if I go cube 2 and cube 3, each one of these cubes is being created because there's a call to the spawn function, which does all the work and places it at XYZ. So XYZ is different here on these two, and they will be farther to the, anyone? Bueller?
Origin.
They'll be, which direction will they be 2 meters farther? It's the X direction, which is?
At the left?
To the east, not to the west. So when you come into a scene, when you spawn into a scene, you are facing north, and you are standing at the southwest corner at 0, 0 of the parcel that is the base parcel of the scene. And the base parcel and the list of parcels is defined in scene.json, and we'll get to that later. But you're always facing north when you first come in. So straight ahead of you is north, to your right is east. And X is positive to the east, and Z is positive to the north, and Y is positive up. And the sun is always to the southwest. So if you get turned around and you're not sure where you are, which direction you're facing, find the sun, think of it as southwest, and then turn the direction you want to look. So I'm going to, if you notice this little dot up here instead of an X on this tab, that means I haven't saved the file yet. Hit Control S, that little dot will turn into an X. That means I've written it out. Now if I go back to my scene, and I'm in it, and I say DCL start. Now, do I already have this browser up running with the scene in it? Like right here? Yes. You're going to find that if you keep doing DCL start, you get lots and lots of copies of this preview, and they're all dead except for the one you've most recently started, right? What you can do instead, to save yourself a little bit of real estate, memory or something, and say start DCL, excuse me, right? DCL start and -B. And what it does is say is start up the engine, but don't start up a new browser. So I'm going to do that. I'm going to wait for this thing to say it's through building. And when it gets down here to press Control C to exit, I'm going to go back here and just hit Control F5 to reload the browser. Instead of having to close one of the browsers that's dead. Just a little bit of saving of work. Well, last time I was at the scene, I moved away from the origin. So it's no longer saying 0, 0 up here. It's saying -1, 0, which is why I am to the west of the corner of the scene. You can see the scene over here on the right, right? So if I get rid of the parameters of distance, of location just the whole position parameter and remove it. Or if I say 0, 0, I'll reload the scene with me standing at the southwest corner of the parcel, facing north, just to demonstrate what those parameters at the top do. There's 2 parameters up here, by the way. The other one, which is scene debug panel, says, give me this control P here. This P, if I press P, I can open and close this panel of information, like how many polys there are in the scene. I don't think that works in the world. So here are the 3 cubes. One's centered 8 meters over from the corner here. 8 meters over, 8 meters up. The other 2 are 2 meters each farther to the east. And now I don't remember which direction I'm facing. I'm all confused. I'm dizzy. And I find the sun, and that's southwest. That's west. That's northwest. That's north. Any questions? How would I make these cubes turn faster?
For instance, you let them move by larger fractions. Yes, there you go.
Mm-hmm. Yeah, this guy is fixed. It comes in what they give me, which is the 30th of a second. But I could say, you know what? Instead of moving a 30th of 10 degrees, I want to move a 30th of 100 degrees. That would make it spin 10 times as fast, right? I hit a Control S. I come back over here. I hit a Control 5. By the way, I stepped to the south of the scene parcel, so I'm going to be in the southwest corner of the scene of the parcel. It's to the south of the scene. I'll be farther away. Do you see that? I am now at the southwest corner right here of the next parcel to the south. You can also see that up in the URL, but I'm at -1 here. But the cubes are going to town now. Still pretty smooth because it's only moving at it's moving at 30 times a second, which is enough to make motion look pretty smooth, and this is moving really fast. I see a little trouble with the rendering of the shadows being a little glitchy. That is the way we're using the Unity engine, and maybe someday that'll be better. There's a lot of things that are going to be better eventually. But anyway, so that's how that works. Put that back there. And let's go on down a little bit further and see what there is down here. Yes, the original cube, the one in the center, I've added one more component to it, which is an on-click event handler method. It's actually a class. It's an event class, and you use the new, and there's a kind of weird syntax here of double parentheses and an arrow and curly brace, but inside the curly braces is just a function that does something. And this, you might not be able to memorize how this syntax works, but you can find examples of it all over the place for setting up a on-click handler and adding it as a component to the object. What you're doing is I'm saying this cube, I want it to do something when it gets clicked on. And what I want it to do is what's inside this function. And this function has no name. It doesn't have a unique name. It just has the class name of the. So this kind of nameless function that's kind of just added in place is called a lambda function. If you hear somebody talk about a lambda function when they're talking about code, they're talking about a function that's kind of defined in place without being named. What happens when you click is that it knows what cube you're on, that you've clicked on, because you're using this cube variable that's here in the outer scope, and you're getting the transform from it, which, if you remember, has position, rotation, and scale pieces. And I'm getting out of that the scale piece, and getting out of that the z axis scale, which is the originally north-south dimension of the cube. and I'm increasing it by a factor of 1.1. I put over here in the comment that this syntax of x times equals y, it means the same thing as x equals x times y. It's just a shorthand that programmers like to have to not have to type an extra x space extra or whatever, right? You can use it with plus equals too to say add y to x. So basically I'm multiplying z times 1.1. Oh, by the way, the reason you do this is otherwise you'd have to take this whole thing over here and say like equals this again times 1.1. What a mess. So to be lazy, you say times equal. Times equals 1.1. It's getting bigger in one dimension, and simultaneously it's getting smaller in another dimension. The dimension that was originally east-west. Remember, that changes as the thing rotates, but it's how it was laid out on the original cube before it was moved. And then, in addition to changing the size and therefore shape of the cube, I'm also spawning a new cube using that spawn color again. This method up here, it's spawn cube. And instead of putting it in a particular place, I'm putting it at a random place. Random returns a number between 0 and 1. It includes 0, it doesn't actually include 1, so it includes 0 to 0.99999, etc. And if you multiply that by 8, I am somewhere between 0 and 8. Or if I add 1, I'm somewhere between 1 and 9. That's my x position. My y position is somewhere between 0 on the ground and almost 8 meters high. And the north-south position is similarly a random number between 1 and 9. Not quite sure why this isn't 16 here. Is it really true that all the new cubes are in the kind of in the southwest? No, northeast? I don't know. Is that true? First click? Nope. They're all over the place. Oh, they are clustered on the left side of the scene, aren't they? How about north-south? Oh, it's relative to the center of the scene, I guess. How did they do that? Anybody have a clue? Math.random is not times 2. Let's just see what it does if we say 16. From 0 to 16. I don't think I want to go plus 1 then. Oh, I know what part of the issue is that you don't want to put the thing right at the boundary of the scene because it would stick out of the scene, right? So they're constraining them towards in a smaller zone.
Okay, there we go.
Where is this entity? Where is the I'm going to leave it as an exercise to be figured out later. Why this isn't a larger range and centered. I would say you might want to go 0 to 12 and then add a couple to can push it away from the edge. But in fact, let's do that. Let's go at 12. Actually, 0 to 1. So I could go. That'd be 0 to 15 something. I don't want that much. Maybe take 12. That let's do that. That says it's anywhere in a range of plus of 12 within the scene. I'm pushing it away, so it's actually going to go from 2 to 14. And And let's see what that does. Where am I going to be standing when I come into the scene? I was in the parcel, so I should be in the lower left corner of it again. And I see 0, 0 up there at the top. So, yep. Now, where do these guys end up when I start clicking on them? So looking at it, none of them are closer than 2 meters to either side. And none of them are closer to, I think this is a better distribution. So I think this is actually maybe, the other one clustered them somewhat. Oh, I'm getting pushed by this guy. That's funny. Am I getting pushed in a circle? I am. How wonderful. Okay. All right. So I think I like these numbers better, but the other was simply clustering it somewhat to the south and west, because the numbers were smaller. They weren't as far north or as far east from the coordinates. Okay. Let's reload this scene and stop being pushed around. All right, so that's the first piece of this review of the lesson 2, and there are three more scenes. We're not going to go through them now, but they explain. The second one puts some more entities in the scene and sees that they all rotate, which is including the green grass on the ground. And the third and fourth show 2 different ways to have only certain things rotate. So if you want to take that as homework to look at, or if you don't know how to do that, the files are very highly commented like this one is. Any questions on that piece of review?
Yeah, Carl, hi.
Yeah.
Can you hear me? I have a question about the rotation. As I see from the code and from the scenes, all the entities are rotating by themselves. I mean, from the center of themselves. And if I want an entity to rotate around something outside the entity, how can I do it?
Yeah, here's how you would do that. I'm going to explain it verbally. You would create an entity that represents the center point. You would create another entity that is the cube, say if you want it to revolve around that point, and make the invisible central entity its parent. And the position of the cube would be offset. It would not be 0, 0, 0, but it'd be some distance from relative distance. Position, rotation, scale of a child are relative to that of the parent. So you could put the empty, no-shaped entity in the middle of the scene. You could make a cube that was parented to the original entity and say 3 meters away. And then you would rotate the first entity, the invisible one, the center point. And that would cause the cube to rotate around it at a distance. Does that make sense to you?
Yeah, it makes sense, but I suppose I should read the DCL documentation about it, yeah? I know what the parent is, but I'm not sure that I can do it inside the code. I should read something about it, I suppose. But anyway, yeah. Thank you. I got the idea.
Actually, let me say, I'll just do this here in this scene. I think it wouldn't be too hard. Let center equal new entity. And I want to give it a, I'm going to borrow from the spawner function here, which is a transform, and add it to the engine. But I'm just going to put it down here outside the function. And I'm going to put the position explicitly to the center of the scene. Now I'll put a meter in the air. I'm gonna hide these other cubes so they don't exist. Actually, if you want to comment out a bunch of code at once, you can hitting Control Z to undo those. Hit /* and go down to the end of what you want to comment out and do that. // and then that block of code is commented out, but what's beyond it is okay. And I'm working with an entity that's now called center, so I'm copying that in my clipboard and pasting it here and here. And I don't want it to have a shape. I want it to be invisible. So now I have a entity in the center, and then I want to spawn a cube. Right? Like that method up above. And now the position of it won't be relative to the scene, but relative to the parent that I'm going to make it, the entity, the parent. So I want it, say, 4 meters to the west initially, no higher or lower than the other one, and no farther to north-south. I'm just going to stick it to the east, 4 meters. I need to put a let or a const here. And the difference between let and const is if you put const on it, you can't assign a new value to it later. You cannot. If you use let, you can. And the other thing I need to do is say cube set parent to center. That's center object. Now there are 2 entities in the scene, and this thing rotates every entity. So the cube will spin as it goes around the center of the scene as well, because of that. Oh, by the way, sometimes when you add a new entity, it doesn't show up in the scene unless you stop the scene and restart it. This is a known bug in the SDK. It's on their list of things to fix. I did not use -b, so I killed that one. And wait for this to come up. Hopefully, the only thing in the scene will be one cube. It's rotating around the center, and it's also turning on its own as well. Yep. It's revolving around the center of the scene, but it's also rotating on its own axis. You see that?
Yeah, great. Thank you.
Yep. I'm going to and drop it into the chat because I'm probably not going to save it this way. I'll put here, say, this is an example of a revolving rotating.
Whoa.
What I want to do is see here, change the source, Explorer here, take this game.ts that we were working on and drop it in here so that you can look at it separately from the class zip file that I loaded up. We have used 1 hour and 20 minutes on review, but I do want to get into Blender a little bit today. So that'll be easier for you to do the next lesson. Let me, I think that the way to do that is to just go ahead and open up Blender and start talking about it a little bit. And blenderfoundation.org is where you download it, and the new version 2.80 is the one you want to be using. If you have an old 2.79 around, at least set it aside, maybe uninstall it and use 2.80. 2.80 is a much easier version to learn. Under the covers, it works very similarly, but the user interface is much more approachable. And they also have added the ability to import as well as export GLTF and GLB files, which is a really big, really useful for us. So here's Blender 2.80. When it first opens up, it has a splash screen. If you see the young lady and her dog, that you know you have 2.80. It also says it right here. If you see some guy doing something else, that's 2.79. You just click anywhere here, and the splash screen goes away. When you first open Blender, it gives you a 2-meter cube, and you can see that it's 2 meters wide if you get the right perspective here, 2 by 2 by 2, and it's embedded 1 meter down in the ground. So the center of the cube is at the origin in the scene. By the way, I'm holding on the Alt key and clicking and dragging, which is pretty familiar to you from other tools. If you've ever used Second Life Editor or just getting around your camera movement and stuff. But that's not the default. The default is the center mouse button rotates the scene. And if you don't have a center mouse button, that's kind of a problem. The scroll wheel will act as a center mouse button on most mice if it has a scroll wheel, but it's hard to work with. So what I typically do is I go into Edit Preferences, and on the input here, I say Emulate a 3-mouse button. I turn this checkbox on because it's not normally on. And now I can use the Alt key and the regular mouse button to move around. Just a little help. You also have these guys up here that you can use to move around, move things around. So if you don't want to click, maybe you have so much stuff here you don't want to click on anything, you can grab this guy and turn, you can rotate up. I'm just moving that X thing around. You also, if you just want to slide the stuff to the side, you can click on this hand and move it while you're clicking on the hand. So that's one way to get stuff moved around. And then if you want to move things in the scene, you use these tools here, like moving. You get, oh, I didn't select this object first. Let me select. If I click on the object when I'm on the selector mode here, you see it all gets outlined in orange. That means it's selected. You can also see the selected over here in the object hierarchy. It's a cube that's selected. Now, if I use the mover tool, I can move the stuff along one axis, or I can grab the thing and move it around. And here's the rotation tool. You see how much you're rotating. Here's your sizing tool. If you grab one of those little cubes, it sizes just one dimension. If you grab a little plane, it sizes it in 2 dimensions. And if you grab this guy here, it sizes the whole darn thing. So those are the basics of how you, get around. If I scroll back on my scroll bar, I pull in and away. I believe that's what this does too. Clicking and dragging it. Clicking, dragging on the hand moves the thing. These guys move stuff. Now, these little buttons up here in the corner are really important. They say, how do I want to be looking at this? If I have it on the solid setting, you see that over on the right of this pop-up, it says solid. I see it as a solid. If I click here, it says wireframe. If I click, I see it as a wireframe. I don't see the faces filled in with material. If I click on the material tab, the material button here, I see a very simplistic rendering of the material, which happens to be just a blank gray on here. And if I click on the, if I hover over this, it's called as rendered or rendered. I see a really high quality version of this cube. If it had textures on it, et cetera, it would be, you know, it'd be looking really sharp. And there is a later section on materials in this class. A real quick preview is when you have you have a hierarchy over here of what's in the scene. And right now there's just one cube, and I've expanded that. And under it, you see the mesh. This refers to the actual points and lines and faces. And under that, you see materials that may be applied to this. I'm going to very quickly show you how to make a red material on this box. There's tabs up here at the top. We've been in the layout tab. The modeling tab is the one that's going to be a little bit more convenient if you want to like build on this thing. Like if you, let's say I want to click on this dot and move it. I'll stretch this thing so that I'm beginning a modeling based on a cube. And the if I go to shading tab up here at the top, that's usually the tab that's most convenient for working on what's on the surface, the material that's on the surface of the object. And you always want to use nodes for your materials these days. It makes the best results for Decentraland. And the nice thing about Blender is that by default, it works with the type of shader. A shader says, what kind of shading do I want on the surface? What do I want the surface to look like? The principled BSDF shader is the one that Decentraland likes to use. There are many types of shaders that you can add. There's just whole menus of them here, but most of them don't work with Decentraland. But the principled BSDF shader, whose heritage is Disney Studios, I believe, it's very thorough. It has many. I'm hitting Alt click and dragging up. It has many different settings, and the output of it you need to put into a material output because that's what actually gets put on onto the these little things are like connectors, right? I just disconnected it, so it has no material on the surface, so it's black. If I connect that, then this thing defines what the surface looks like. And here's the base color. Let's say I want to make it red. Now I have a red, what is that, a trapezium? I don't know the word of this shape. Anyway, but there's other things you can do, like you can make it shiny instead of have shiny metallic be 0, but make it 1. Now, if you have the right kind of light, you see that the surface is shiny. And what else might I want to do here? Put some roughness on it. It's also kind of rough already, but maybe I don't want it to be rough at all. If I get rid of all the roughness, you actually see a huge reflectiveness because it's shiny. That's because of this material here, this metallic setting. So that's a kind of a rough idea of how materials work. What you do is you expand the object, you expand the cube, and underneath it, there's material, and you go to town in the shading tab on the BSDF settings. There's a lot more to materials than this, like transparency, like applying texture images to the image. By the way, do you see that there's like an image reflected in this shiny surface? That is this picture here. It's in like the surrounding world is being reflected. You can pick what you want for the surrounding world. And in Decentraland, something that's real shiny, I'm going to make this super shiny and not at all rough so that you can actually see how really shiny thing looks. Roughness, do I have that turned down already? You have to Alt click to move it. Roughness, I have it turned now all the way down. So it's really mirror-like surface, but reddish. I'm going to save this Blender file. I have some models here in a directory that this is my models library, by the way. I don't have that in the scene thing. Instead, I save it in a OneDrive folder so that they're all backed up to the cloud. And I have models from different people in different companies. So in here, I'm just going to create a new directory. That's this little button right here, and call it shiny red thing. And go in that folder. The Blender file would be called untitled.blend, unless I say it to rename it shiny red thing. Does shiny have an E in it? I think it doesn't, but there it does. So I'm going to save it as a Blender file here. And then I'm going to export it as a GLB. So that's on the file menu under export. You have many different formats you can import and export from Blender. So if you get an FBX file from somebody or a GLB file from you want to do some work on it and then export it to GLB, you can colladas, FBXs, OBJs, right there are all common formats you might end up with a copy of. But when you want to export it as a GLTF or GLB, you get this thing about, well, where do you want to put it? So here's a folder thing. You can always create new folders if you want. I'm just going to put it in the same folder as the blend file. And I'm going to, I have an operator preset that I use for GLBs and GLTFs, but I'm just going to show you what a couple of settings do here that you might want to know about. You definitely want to have +Y up. That says whatever up is in the Blender scene, apply upness to the Y dimension in the output. If you remember, Y is up in Decentraland. This doesn't mean what it kind of says. It doesn't say turn Y into up. It says turn up into Y. So you want that checked. And it is checked by default. Also, later in this work, you might find a reason to apply a modifier to the model. And it's kind of a transform that happens. It's not like built in the mesh. It happens like when you do an export or rendering. And generally speaking, you want those on, but there's no modifier in this object, so it wouldn't matter. And then finally, you want to pick what format right here that you want to export in. GLB puts everything into one file, and it's a great format, and it's compressed. And unless you have a reason to want to mess around with the textures as separate files sitting outside the GLTF, in which case you would use this, there are no textures in this, so all you'd end up with is a GLTF and a bin file in that case. Let's use the GLB because it's a single file. It's in the right directory here, shiny red thing. It's going to be called shinyredthing.glb. Hit the export GLTF. Takes a moment, and then it comes back to here. Everything's saved. I found out that when you close this Blender, it's going to say, hey, do you want to save your work? Well, the only thing I did was I set the settings I wanted for GLB, so I say sure. If you're not sure, if you think you might have broken it or something, then you might want to rethink that. So now if I go to Windows Explorer, I'm going to add this to a scene, to a DCL init scene. So I go to my, well, first I'm going to make the scene. In this class, you're allowed to make scene. Make a scene. That joke's getting very old, I know. Yeah, that'll do. And here I'm going to do a DCL init just to get myself a scene into which I can put this thing. And now I want to explore at this location, and I want to create a models directory here. I could have done that with mkdir too. And if I was making a complex scene, I would make subdirectories here for different models or groups of models. I'm not going to mess with that on this one. And instead, I'm going to go in a different window over to OneDrive, AV Data, 3D Models, Carl Fravel, shiny red thing. And in here, I have 3 files. My Blender file, the previous version of my Blender file, because every time you do a save, it keeps a backup of the one earlier copy. That's kind of a nice thing. I don't need that. I'm going to delete it. And here's my GLB file. By the way, in Windows, if you double-click on a GLB or a GLTF, you get to see it in the 3D Builder or 3D Viewer apps of Windows. And it has a different scene surrounding for shiny stuff. It looks a little bit like something from the first Superman movie. Or anyway, so I want to put this into this models directory here, so I click it and drag it into my models directory. And I don't want to have to remember how this thing is spelled, so I'm going to click on it to get it into rename mode. Alt-A to get the whole thing. Control-C, excuse me, Control-A and Control-C to get the name of the file into my clipboard. Then I'm going to go back to the scene and go up to the game.ts file. There's much stuff in here I don't really need, but I'm going to delete. I may want to borrow some of the code. So I'm going to say start by pasting my clipboard in here because I don't want to lose that. It's a syntax error, of course. But I'm going to say that I want a new GLTF shape. I'm not sure whether it's all caps or not, so I'm going to say G and let it give me a suggestion of things it knows. Turns out it's all caps. And the parameters in a GLTF shape are the location of the file. So it's in the model subdirectory, and it's called this thing here. I have just given the script the instructions to pick up the shape from that GLB file. And I'll say I want a new entity. And I'm going to say, oops, I need to give these things names. So entity, let's say red thing. Like this. And let red thing shape equals this new shape that I've gotten from the file. And red thing dot add component. I'm going to add the shape to the otherwise invisible point in space. And it now knows even the things that I've made. I just typed R. I need a transform. They'll put this thing in the, I need a transform here. Oh, that was in the spawner here. This will do. Yep. Red thing. I'm lazy. I don't like typing because I make typos. Click red thing, Control-C, double-click cube, Control-V. And by the way, I don't like the word red thing without a capital T here, so I'm going to right-click on this and say, rename the symbol. And this thing is smart enough to know that I want to make it red thing everywhere, that is in the code. And I don't want it to be XYZ. I want it to be 818. You don't need spaces in here. And it's not going to show up unless I make it, add it to the engine. So I'll say engine.add entity of red thing. So let's see. I've given it place. I've given it a shape. and I've added it to the engine, and I think all the rest of this code can go away, and I'll just have a red thing. Oh, no, it worked. It's not rotating, of course, because I took all the rotator stuff away and I didn't make that part of it, but there's our object. Somebody has a car over there. I wanted to point out one thing here, which is in Windows, your paths, the directory names are supposed to be separated by a backslash. In Linux, Mac, and in code like Typescript, typically use a // even when you're on Windows. So if you do something in your, I've done this sort of thing before where I say, where's the model? Let's see, it's in, especially when I have a lot of subdirectories down to my thing, I'll copy from models over through all those directories and put that in, and then I'll copy this in. And if I don't forget to change the backslashes that may be over here, it won't work. In fact, it gives you a little kind of a weird little error like this. It's not really an error, but it's saying that backslash is doing something different to the S. It means treat that S differently. And I don't want to. I want it to actually be a path name. So that works. Any questions on this scene? On Blender? On exporting things from Blender? Where's my Blender? There it is. Nope, that's Builder. Did I close Blender? I closed it. Well, the nice thing about Blender is that, like many modern tools, it has I click here. I'm not interested in this thing. If I was going to import, that's what I should do. I should import a GLTF. But it also opens recent files. And here's shiny red thing. So here's my, oops. It asks me if I want to save this little cube. I do not care about this cube. So I say open recent, shiny red thing, and I say discard the changes of this cube scene, and it'll load my shiny red thing. But I should import a GLTF or GLB. Maybe something that has some materials and textures. You can see how that looks, because that's part of the assignment is to get familiar with bringing things in and out of Blender. So what I'm going to do is say File, New, because I want to clear out Blender. I want to make it empty. Because when you import a GLTF, you have to do that into an empty scene. So a new scene is not quite empty. It has this cube, which is selected, and I hit the delete key and it goes away. Now I want to say File, Import, GLTF. You might, for example, want to import and mess around with one of the curated objects that come in from your builder scene. Change the color on it. In fact, maybe we should do exactly that. Do I have a scene that has, well, there are trees in it? I think I do. Let's see. Let's go here. Nope, let's go here. I think that well, let's just start from scratch and get one. So I'm going to open up Builder. And create a one parcel scene. And let's find something that we want to mess with. Maybe we want to think of something with a fairly simple material. Just give me a moment. Maybe it's rock. Yeah. Maybe you want the rock to be brown instead of gray. Let's try that. So I'm going to export this, download the scene. And in this zip file here, I have a models directory that has both the floor and the large rock. And one way or the other, and I'm not quite sure how they're doing it, but the Decentraland curated content, the GLB actually has an external texture file. It's the only ones I've ever seen where the texture file is external on a GLB are these guys. You need them both to be able to open it the way you want. So I'm going to go to, we can work in this scene. Why not? We have a tree in here. Let's see, where is it? I'm opening up Explorer on that scene. I'm going into models, and I'm going to paste those two files in here. And I'm going to, first of all, go ahead and put this rock in the scene, getting the name of it, going back to my code, and just dropping the name here temporarily. I'm going to grab this stuff and put it down here. And I want to rename these guys because we have a name conflict now. But if I rename it here, it's going to rename it up there. So I'm going to try this clever little trick of putting a comment around this stuff so that it won't know that that stuff is needing to be renamed. And down here, I'm going to rename the red thing to rock. And the rock shape, rename that to be rock shape. And I'm going to need to check that every place here, yep, that's good. And then this GLB file name replaces red thing in this part of the code here. And then take the comments back off of here. And now they're going to be in the same place. I don't want them in the same place. So let's put the rock farther back in the scene. Why not? So maybe like 11 meters back from the...
There's a mistake in the name of the file.
Oops.
Shiny rock file.
Because of the E?
No, there is no shiny. No shiny at all.
I see. I didn't select all the right stuff to replace. Thank you. Nice catch. It would have been an error maybe in the console at best, and it certainly wouldn't have worked. I don't see any red dots over here. I don't see any red curlies. So this looks like it might actually work. Of course, seen right now, the rock is just going to be gray. And it might not show up because, well, first of all, the engine isn't running. But even if it was, thank you very much for catching that error and saving us some time because we're getting a little close on time here. Debugging is the slowest stuff you'll be doing. There's your rock. Now I want to import that rock into Blender and change the gray on it to brown. So I'm going to close this and open Blender. And what I want to do is open the Blender on this directory. I copied it, just to save myself some time to digging around for where, oh, import GLTF, try that again. Oh, I had a little angle at the end, there we go. I go into the models and I open up the rock GLB. Typically, you wouldn't do this inside your scene. I forgot to delete the cube first on that new scene, didn't I? Oh, I just do that now. There's the rock. What I should have done is open up Blender, did a new scene, deleted the cube, then did the file import. I just didn't delete the cube first. And so here's my rock. Over here is my rock. By the way, the light that is default in these scenes is like a spotlight that's just a lamp somewhere. I often like changing that. So I click on it, go down here, and say I want it to be a sun up in the air. And I do not need it to be 1,000 times as bright as the sun, just 1 times as bright as the sun. Thank you. And now the scene is illuminated more like it would be illuminated in Decentraland with the sun up above somewhere. And then I can affect the angle and all of that, but I'm not going to do that. The rock has a mesh. The mesh has a material. The material is, I'm going to go to the shading tab to work with that material. And here is the cycles node structure that it came up with. It actually put one node over the top of the other. And it has a whole bunch of stuff out here that I don't think I care about, but the main thing I care about is the color that's being applied, which is coming from, what are these? Excuse me, I'm not familiar with this node structure. Oh, it is coming from this file, really? Oh yeah, there was a file over here, wasn't there? That was the thing I was saying. It was kind of unusual, file 1. By the way, let me open it up and show you what it looks like inside. It's not really a kind of typical texture map that kind of lays out the surfaces of the object. It's just a color palette. And they're picking a gray using a UV map, which we'll talk about later in the course. I think I'm going to add one more lesson about UV mapping. And I don't really want to use that thing. I'm going to click on a few few nodes in the map and delete them. And I'm just going to come here to the where is it? Deleting that. I'm just going to say I want the base color of this rock to be brown. Brown, by the way, is a dark yellow. So I'm going to pick a yellow slightly on the orange side, so slightly reddish brown, maybe about here. And then I'm going to pull down this thing here to get brown. Is that a nice brown? Do I like that? Looks a little greenish to me. So maybe we want a little different color here. A little redder. Okay. There's a nice brown. There's still some loose nodes over here that I don't need in this shader map. So I'm going to delete them just to save a little space in the file. And then there's a strange thing that when you import a GLB, it says, you know, I'm going to give you emissiveness in case you want this rock to glow. Like now it's glowing in the dark. But I don't really want that. So I'm just going to delete this emission and this thing that says add the emissiveness to the color. So I'm going to take that out. You see how easy it is to work with these things. Just delete this and move this material output node, which you have to have to get something out to the output, and come up to the connect the BSD to the surface. And it's brown. We have a nice brown rock, so I'm going to do a file save save as, and I'm going to go ahead and put it in the same, why not? But instead of calling it untitled, I'll call brown rock. So we keep the Blender file around in case we want to quickly go back and make a change here. And then I'm going to file, export GLTF or GLB, but I'm going to actually pick GLB, which it was already selected. Out of habit, I say apply modifiers. And it will put it in this as brownrock.glb in the same place where my Blender file is in my library of content. And I'm going to go get that thing and put it into, there it is. Get that brown rock GLB and put it in my scene models in here. and get the name of that. F2, Control A, Control C. Go back to my code and put that GLB name in here instead. Now I have some things in my models directory that aren't being referred to in my scene anymore. It won't hurt anything for now. I think I need to restart the engine here. That is a mighty dark brown. Either that or it's black. Go back and look in Blender and see if I can figure out what's wrong here. I'm going to actually look at the as rendered version of this. And maybe it's just really dark. Just for grins, let's try lightening it up. I think that, you know, they've turned down the brightness of the light in the SDK recently. It's not like everything's so glaring bright. BSDF, surface, base color. So I think this should do it. Save, file, export, GLTF. Remembers where I wrote it last time. It's remembering the settings I have. I'm just going to double click here. And this time, I'm not going to trust that I necessarily got it right. I'm going to see what it looks like in the viewer. I'm double clicking here. It's brown. Okay, so copy it and put it into the scenes models folder over the top of the other one. And I think I didn't stop the scene here. So I hit Control 5. If it comes out black again, I'm going to restart the scene because sometimes changes in your models don't get reflected unless you restart the engine. Ah, there it goes. It's brown now. There is less light in the scene than there is in the Blender view. It's darker here. Blender view has a more illuminated texture. Questions? I'm willing to go a little long.
Is there a possibility to get a reflection on the red cube, the reflection of the brown stone?
No. Decentraland does not support a mirror. This is not really mirroring anything that's in the scene, as you can see. It's mirroring some scene from some city somewhere.
Buckingham Palace.
Yeah, is that what it is? I'm not saying that they will never introduce it. If Unity as a game can have mirrors, then this engine probably can have mirrors. But right now, they only have about 1,001 things to work on, and getting a mirror to work is not anywhere near the top of the list. So maybe someday. I think they will make the scene that you see reflected a little more representative of Decentraland by going maybe to near one of the plazas and taking a picture there and having that be what gets reflected in the material. It's actually not reflecting the world, it's reflecting an image that's part of the material. And so it's not reflecting arbitrarily what's next to it like you would want. Any other questions? The Blender Guru tutorials are very good. And he's been updating his content for 2.80. Be sure if you get a tutorial or a manual or watch some YouTube videos. Make sure you're watching ones for 2.80, which only got released publicly, like official release, I think August 3rd. They've been working on it for a year. So there's a fair amount of 2.80 content out there, but start with Blender Foundation's own documentation, or I recommend Blender Guru as a really fine set of tutorials. Let me go back here to see if I have a comment. Where is the... There it is. Lots of questions in chat that I have been ignoring. The render engine does Decentraland accept. Decentraland accepts shaders. The shader that it likes is that principled BSDF or transparent BSDF are the two shaders that you will, and also emissive. Those are the three that you can use that are shaders. There's other nodes that you would use in cycles nodes that, or in the shader nodes that you use to hook things up, like texture maps and UV maps and other things. But the shaders that actually control the color and the shininess like that, you need to use the BSDF, principled BSDF, transparent BSDF, and emissive. EV and cycles are rendering capabilities in Blender to render those shaders for viewing in Blender. It doesn't actually export the rendering engine, it exports the shaders, and it uses the Unity rendering engine in Decentraland. I hope that answers that question. Eevee, by the way, when you're working in Blender, you want to use Eevee if it's basically what you get when you click this right-hand button up here, as I have done. It is an extremely good rendering engine. It's very fast, and therefore they're able to, used to be you'd have to work in this material view, which isn't nearly as realistic, or even in just don't put a material on it, just treat it as gray until you're ready to see it, and then you would go to a rendering process which took seconds to render it nicely. They have now put a very fast renderer in here called Eevee, and it's very real time, just like Decentraland is. And it's a really good renderer. So that's what Eevee is. But the shaders here are what determine what will go out through the GLTF or GLB file to the Unity renderer in Decentraland. More questions? Did I miss anything up here? I think you were giving, I think I got what is there any more verbal questions? Am I still being heard?
Yes.
Yeah.
Okay.
Yep.
All right. Okay. There's so much silence. The silent questions. This is a pleasure. I am enjoying this class more than you know. I think about it most of the time I'm awake. I'm having so much fun with this, and I enjoyed putting together the new sample scenes so you guys can kind of walk through that. And I'm going to take a few more minutes and stay here and walk through the second, third, and fourth versions of that scene. If anybody would like to see a little bit more in depth about code, officially we're past our time, but I will do that. Is there anybody interested in seeing more about those scenes in code? I think Zach said yes.
Yep.
Yep.
Right.
Okay.
Right now?
Yep. Yeah, I'm just going to stay on and walk through those other scenes if people would like that. Okay. I know it's been a long class, but I will do that, and happily. So let me go back to...
Carl, can I ask a question? And
Yeah.
So when it comes to rotation, along the X, Y, and Z coordinates, could you just explain that? Because
Yes.
I always get it
Oh,
mixed up.
it is confusing. Let me go to the, I don't want to save this scene. Oh, I already did. I had to get the, what was it I was adding here? Let me open up one of those sample scenes. I'll open up the second one, which I did not mess up today. Actually, I skipped the second one. Let me go down. Let me go back one. We're going to hold on rotation for a bit while I do the second one. Is that okay?
Sure. That's
It's not a real long one, so just
No, that's okay. Sure.
okay. Can this be moved? Yes. Look at that. All right. Change directory. Lesson scene 2, one box. This is a very simple scene that just shows you how to put one GLB and one simple box shape. I took out the rotator stuff from the default scene. I left the spawn cube in here, and so the code down to here is the same as the DCL init scene, except without the rotator stuff. And then I also spawned without using the box spawn cube, I gave lines and explanation for bringing in a Blender cube, which is included in the scene. So you can see the explicit code here, as we've used it a couple times today, but this is the simple version of it for bringing in a GLB. If you wanted to bring in, for example, some GLBs from the builder, don't forget, though, that file that is outside the GLB is necessary. Okay, so I'll go now to the rotator scene. This again is very similar to the default scene you get, except I've added a few things in from a builder scene. So in a builder, the builder creates a invisible entity at the southwest corner of the scene. It's unrotated and it's unscaled. It's normal one-time scale. But they never put a shape on it and make it visible. It's simply used as the parent for everything else in the scene. The reason why you would do that is you can collect a number of objects into a parent, under a parent. The parent object itself may or may not have a shape, may or may not be visible. But when all the entities that are parented by the base entity, I'll call it, will be rotated, positioned, and scaled by what you do to the parent. So if you had a scene that was fairly complex, had a bunch of furniture, etc., but now you just need to move it over a foot, right? Move everything. You will wish you had parented all of those decorations to a parent entity that you just moved it. You can also resize it. You can shrink everything a little bit to make it fit better somewhere. So it's a good practice to have a scene entity. It is not uncommon to put it right at the southwest corner of the scene. You could also put it in the middle of the scene by putting it 808. You do have to put the transform in it and add it to the engine. But it's invisible. It's just a reference point that you're going to parent other things to. One moment. Okay.
And why do we need this transform component?
You would not need to specify any of these things. This scene could absolutely be just this. Or you could have no transform at all, which would be the equivalent of that. But as soon as you wanted to mess with moving that around, you'd wish you'd have that stuff in there. So here's code of what it would be. By the way, quaternions are the official way to rotate things in 3D space in games and stuff. And they are incomprehensible for the most part. Somebody explained it a little bit last week. I wouldn't say that that taught me exactly how it works. There is a 3-parameter way of rotating things called Eulers, and there's conversions between Eulers and quaternions. The reason why you want to use a quaternion is if you want to make gradual rotations, like interpolation of something rolling or spinning as it moves through space. Eulers have this problem. If you keep rotating them a certain amount, after a certain point, they just kind of snap back or flow back to a previous setting and rotate again from there. And it's just ugly. So if you want to have something, you just keep rotating indefinitely through many rotations. You've got to rotate it using a quaternion methodology. So that's the reason why. But when you just want to set the rotation of something initially, a Euler works fine, and internally the engine converts it to a quaternion. So that's the scene. Then I brought in a ground cover and a tree from a builder scene. So the builder scene was a one parcel scene. So it had one entity that had the flora-based grass name. They actually have a model with that has a texture on it. It has a grassy texture, kind of. It's not just plain green. And so here is the code literally copied from the output of the builder, the download of the builder, for the grass and for a one tree. This code here is all identical to the previous scene 1, lesson 1. It has the rotator in it. It also has a cube from Blender brought in.
Hey, Carl,
So yeah,
how do you change a TGA file into a GLB file for like a flooring or something?
yeah. The best tool I know for working with graphic 2D images is GIMP, G-I-M-P. It's a very good graphic editing tool that is free. It's open source. Not terribly hard to learn. It's, I think, a fairly good competitor to Photoshop, which is not free. I used to use Paint Shop Pro many years ago and stuck with it for a long time. And this last year, I decided to bite the bullet and learn GIMP, and I'm very glad I did.
You can import a TGA and GIMP and then export it as a DLB.
You can import and export different formats. Let's just open up GIMP for a second and see if it's true that it can. Import a TGA.
I just asked because in some of the builder scenes, if you go into the models folder, it'll show the GLB file or whatever, and there's also like a PNG file in there that's the actual image.
Yep.
So
A PNG is not a TGA.
right.
Okay, but if some of them have TGAs, you would need this. Maybe it just has the ability to open a lot of different types.
I just asked because I downloaded a TGA from the web somewhere, and I can't figure out how to get it into my scene.
Here it is. Yep.
Okay.
Target images is a format that can work. You can see it just goes on and on. It's a wonderful tool, and it can export. Once you get something in here, if you just do a save, it'll save it in the native format of GIMP, which is XGA or something. Reasonable thing to do if you're building layers because it stores everything you've done. But once you want to export it for a JPEG or a PNG, they're compatible with Blender or with materials on primitives, then you would do an export.
Okay. Use GIMP.
Okay.
Thank you.
Yeah. GIMP. It's great. Great tool. Rotation. Yes. That's in the update method of the rotator, right here. You could rotate do a rotation of the transform here by opening up the rotation, getting the X and the Y and the Z of it in Euler format, or the XYZ W, I think it is, of the quaternion, and messing with those individual numbers and putting them back into the transform. Painful to do, especially in quaternions. So they gave us some shortcut tools to do that, which is based around the idea of a 3-parameter. It's in other words, a Euler format. Euler, by the way, is E-U-L-E-R. I believe he was a geometrician, a mathematician. The vector3 class has just the class itself has a series of methods on it that are useful for rotation. If you say vector3 up, what you're getting is a 3-parameter vector that is pointing up. And the effect is that if you then rotate it by that three-dimensional vector and with the up on it, and whatever the factor is you want to rotate it by, this is the 30th of 10 degrees, it gets the job done for you. So let's talk about rotation on the 3 axes, X, Y, and Z. First of all, it is a left-hand rule rotation. So in this case, for example, this number is a positive number. It's a small fraction times 10, so it's greater than 0. It's positive. So it's a positive rotation. If you think of what that means on a left-hand rule is make a fist, stick your thumb up, and then uncurl your fingers a little bit so that they're curled but not embedded in your palm. And if you rotate your hand the direction your fingers are pointing, you are rotating it in the positive direction. A right-hand rule would rotate positive the other direction, but in Decentraland, the coordinate system is based on the left-hand rule. And so if your thumb is pointing up, then your rotation is going to tell you what to do if you rotate on the y-axis, because y is positive up. There's a method down here. It just kind of reverses it. There's also left, right, forward, back, or something methods, and therefore the other 2 axes. So if you remember that on the x-axis, we're going to use the left-hand rule. Just tip your curled finger thumb up thing over to the right so that the thumb is pointing to the right. If you remember x is positive to the right, then if you rotate positive on x, which would be, instead of up, you'd use right, then a positive rotation would rotate the top of the object away from you. Similar for Z, if you arrange your hand, maybe put your arm out to your left and you raise your hand so your left thumb is pointing forward. A rotation positive in Z, which is called forward, if I remember right. Yeah, forward. I believe there's also a backward. That would be the reverse of what you want. Anyway, so use the forward method instead of the up method to rotate it positively, and it would roll left-hand rule, thumb pointing north. The fingers would indicate that a positive rotation would rotate the top of the object to the left. Catherine, was that you that asked the question?
No, it was me. I'm about it.
Hi.
Yeah. I have to be honest, I'm not sure I get it. It's a bit
Yes, it is. I agree. So it takes a while to sort this out. What you could do is take, first of all, there are some pictures out there of left-hand rule rotation if you can find one.
yeah,
I think.
I think someone in the class shared it, and I remember, and I
Uh-huh.
have my in that position. But anyway, not to hold back the class. Don't worry.
Yeah, if no,
okay.
I'm going to go through the up again. I won't go through all three of them, but I'll go through the up one more time. Left-hand
Okay.
rule, stick your thumb up, and you're
Yes.
using the up method. So that means I'm working with the Y dimension
With the
as
Y.
if thumb was up, right?
Yeah.
And then I am going to, if you're looking at my screen, I'm going to rotate it with a positive number. That means I'm going to rotate it in the direction of rotation that my fingers, curled fingers, are pointing.
Okay.
It's as simple as that.
Okay.
You know, if you're using right hand, it would rotate the other direction. It'd be the wrong direction. And if you put a negative on here like this, that would reverse the direction of rotation. It would go the opposite direction of what your fingers are pointing.
All right.
Carl, and maybe can you maybe show us another rotation that is not up, but some other rotation, just to see it, how it goes in the viewer?
Yep, I'm going to copy this line, Control C, and I'm hitting Control V twice, and then copy, just to leave the original there. And I'm going to have it roll away from you, the top moving away. That would be an X-axis roll, right? X is being the east-west axis if you're looking north. And so I'm going to say right. Right is the positive direction on the axis that I want it to roll on, rotate on. I want it to rotate on the x-axis, which goes, when you're looking north, it goes from left to right. And right is the positive direction. And so with the left-hand rule, this cube, instead of rotating around the vertical axis, rotating around the horizontal axis that's left or right. And the top of the cube should be rolling away from us, because that's the direction your fingers point when you point your thumb to the right. So let's see what happens. I'm going to speed it up a little bit. Be a little more fun. This is in the lesson 2, scene 3. I need to go out to the command prompt. That's where I am. I'm going to be to the left of the corner because it's -1 up there. I was in a scene that had everything rotating, but it is indeed rotating the top away from you, right? I forgot what scene I was in.
So the center of the rotation is this scene entity that is invisible.
Oh, it's more complicated than that. I think you'll find that it's not happening here. That's interesting. Before I changed it, the purpose of this was to show that everything's rotating, including the individual things within that. I could have done this on the DCL init scene, and it would have been more obvious. But you get the idea. It's rolling that direction. Let me actually fix this. It's not quite what I meant to do. We're going to. I'm just going to copy that line and reinstate that and close this, and instead go to how many do I have here? 5. Okay, so 6 is what I want. 6. Roll away. Actually, I should say roll. Yeah, that's good enough. You get the idea. I'm putting that line into a simpler scene. And I'll put a comment on it and save the scene for you. So rotate the box positive on the x-axis. Left hand rule, thumb to the right, fingers point the direction of roll. By the way, we're kind of rolling and rotating centric in this class because the DCL init scene does that, but that update function could be gradually moving a snail across the scene. It doesn't have to be rotation. It could be making one of our classmates, Crypto Frontier, had a bunch of trees growing. The update function was increasing the size of all the trees and then shrinking them again. Here is our scene. As expected, the top of it's rolling away from you. If you kind of imagine your left hand held up in front of the screen and your thumb to the right, and the fingers pointing the direction that the thing's rolling. Is that starting to get clearer? I hope.
Yes, yes, thank you.
The second example in my series that I attached today to the document and linked from the thing, the second example adds adding the models to the scene. Yeah, all of these add some models to the scene. The second example has just a cube and a GLTF cube, showing you the code for each of those. These other scenes, later scenes, have often several objects in them. I probably will add one more scene to the end to show how to use, there's a spawner function in there, but I have a module that I import into my scenes that has spawner functions for all the different object types. It's really nice to use, and it has 9 parameters instead of 3, so you can specify the initial rotation and size as well. I think I don't have time right now to add that, but I will add that to that collection, and you can see that later. I hope that helps. But I was going to go ahead and walk through these other scenes and show you what they do. So, yes, this scene. Scene 2 has one box and one GLB, and we looked at that, the code of that a moment ago. It was the DCL init scene with the rotator stuff taken out, and in addition to the base cube, it also added one GLB. So you have the very basic code for adding each a primitive and a GLB. Scene 3 is what people ran into a lot when they try to add other things to the scene. I don't think I've installed the SDK yet in this one. So I did an npm I and a DCL start. And here I brought in a ground cover and a tree, at least from a builder scene, and added them to the initial DCL init scene that has the box and the box generator. But as people found, everything rotates. Oh my goodness. Like, this is really confusing, right? The whole scene rotates, but also the things in the scene rotate. So the question is, how do I have the only the original box and the extra cubes that it creates rotate? The other things I don't want them to rotate. A few people saw this. I think many people may have seen it. So I'm going to show you what has to happen to the code to do that. So let me start with showing code from this scene where everything is rotating. Explain it a little bit. In order to get all the cubes to rotate, they created the Decentraland team created a for loop here that loops through all the entities that are in this group variable. And the group variable says, engine, get me a component group, I'm going to put in this variable called group, of everything that has a transform. Now there's everything that could be rotated. And as more cubes get generated, they get added here, but so does everything else I put in the scene, unless I suppress them here somehow, so that they don't get rotated. And so I have two examples of how you would do that in code. They're in scenes 4 and 5. In 4, what I do is I say, I exclude explicitly a few other things that I've added to the scene that I don't want to rotate. And I'll show you that, but it's certainly not how you want to do it in general, because you may have a lot of things you don't want to rotate and only a few things you do. So let me show you the way that a simplistic way to do it. And we'll do that first. All right, here's the rotator. Almost exactly like it is in the initial scene, except I do this test here. And I put the rotation stuff inside the curly braces of the if test. And I say, well, if the entity is the scene, if the entity is not the scene, and the entity is not the grass, and the entity is not the tree, then go ahead and rotate it. It's this line here. Because I have those other three entities that I've added to the scene, I don't want them to rotate. This says not equal. This is logical and, so I have three not equal statements. So it's not equal, the entity that I'm about to rotate is not the scene, it's not the grass, it's not the tree, then go ahead and rotate it. And it works. The scene works. I'm doing npm I because when I zip these scenes up, I did not put all that SDK stuff into them. So they're small. And the only thing here that's rotating now is that original. Actually, what's rotating is what I use the spawn cube, and here, let me show you how I, oh yeah. Everything is rotating except what's the third thing in the exception? The tree, the grass, and the scene as a whole, because all these objects are parented to a scene the way the SDK does it. So it was rotating the scene, and then within the scene, it was rotating everything in it also. So now the only things that are being rotated are the things that weren't excluded in my if statement here, which are the cube, the original cube, and any cubes that it spawns by being clipped on. They're all rotating because they're not excluded by my if statement. And also the GLTF cube that I put in from the second scene example, it's rotating. But I don't like that way of doing it because I probably have 3 things in some scene that I want to rotate, especially if I want to rotate them like all the same. If I want to rotate some things, one thing one way and another thing at a different speed in a different direction, maybe I'll probably have 2 rotators. I'll make 2 rotator systems and add them both to the engine, and each one of them is working on just one object instead of on a group of entities. But let me take this one step further. Because I had mentioned that one way to do it is create an array that contains the objects that you do want to rotate. It's appropriate for this scene. I did the npm-i before opening code because otherwise the absence of the SDK would make all the syntax, all these things come up unknown. So if you see your scene is like, well, it's all full of syntax errors, and a moment ago it was fine. It's probably you've opened a game file that's not in the context of having it being in a scene that has had DCL init or npm-i run on it. All right, so at the top of this scene, again, it's very similar to the previous scene, except I've added two things here. I don't really need this, as it turns out. I'm going to take it out. It's confusing. So I have an array. Arrays are denoted by square brackets, open close bracket. It's an array of entities. The way you say that something is an array of something is you give the type, and you put the array indicator after it. So this is an array of entities, and it's a variable called rotatables. The colon says that this thing is of this type. Rotatables is of the type an array of entities. An array is, if you think of a spreadsheet that has a row, all the cells across that row are an array of values in that row. So the row is an array. I think it's probably the easiest way to think of it. And the array has a size. It's how many cells have content. And the first cell in an array is cell number 0. So arrays are always, the cells in them are numbered from 0. The equals empty array says initially this array has nothing in it. I have actually set up an empty array. There's no cells in it yet. And then in the, I do this, I make use of it in the spawn function because the spawner is exactly what's creating the cubes that I want to, those cubes that are being generated, the initial one and the ones that are being generated by clicking. Those are the ones I want to do. So inside the spawner function, no, I do need that. Sorry. Inside the spawner function, I take this new cube that was generated in here and insert that into the array in a certain cell. Which cell do I put it in? Well, the very first time I create one, I put it in the 0 cell because number of rotatables is 0 initially. So the first time I create one, I put it in the 0 element or cell of the rotatables array. And then this little plus plus is a shorthand for what I could do otherwise, which would be like this. Increment that variable so that the next time I put something in the array, it put it in the next cell. But a number of languages have the shortcut that when you use a variable, if you put plus plus afterwards, it increments the value of it after you've used it. So the first time around, I'm using this as 0. So it's a 0. This goes into the 0th cell, but immediately I'm incrementing it to 1 for the next time. If you put the plus plus on the front of it, it actually increments it before you use it. Rarely used, but sometimes that's a useful thing to do. But if you see plus plus after a numeric variable, it's because it's being incremented after it's being used. So I'm building an array that starts with, that contains everything that was built with spawn cube, which starts with that first one that's in the center that you click on, and every other one that gets generated afterwards. But because I don't add any other entities to this array, then down in the rotator, up in the rotator, I'm iterating not through that group, but I'm iterating through the rotatables array and rotating everything that's been placed into it. Any questions before we demonstrate the scene? Okay, let's take a look at the scene. I have not developed a habit yet of putting the -b on the TCL start. Works. The source code to all these scenes are available to you. I'm going to actually do not what I said I wasn't going to do. I'm going to make one more scene, and I'm going to use it to introduce how you import a module into a scene. I'm going to import the spawner functions module that I've been working with for a while to just makes it so much easier to set up objects in a scene. So we're going to make a directory called lesson 2 scene 7 spawner module. That was the F3 that I just typed after typing C. It duplicates the previous line beyond wherever you've typed. So it's just a really nice shortcut. DCL init. Now I have made available to you a few GitLab projects that have some of my working code in it. And one of those is called Scene Base. I'm going to actually go to that that scene in my directory here and get a couple things from it, but you should know that you have access to it too. I've put them into a folder, my various materials that I use again and again. I put them into a library folder. And this scene-based scene has, in the source directory, it has a module subdirectory. And it's this file right here, spawner functions, that I'm going to use. I'm putting it in a subdirectory of the source directory called, that new subdirectory is called modules. It doesn't have to be called this, but this is what is typically being used. And in there, I'm going to drop this file. And I'm going to also go back to my scene base. Go up to the source and open up games.ts here because I'm going to borrow a few lines from it too. In particular, I'm going to borrow this import line of the spawner functions in the module subdirectory, and I'll show you that a little bit more when I put it in the other file. I seem not to have opened up the other file yet. So that's in class lesson 2, 7, source, games. I'm going to put this up at the top. It's an import of this module in module subdirectory spawner functions. And you don't put the .ts, and it seems to work better, I think, if you use single quotes. That's what I could be absolutely wrong on that, but I remember struggling once around something, and the syntax for this on the right is a little bit weird because you don't put the TS, it's just the name of the module. It's assuming it's TS. And you put dot before the slash and then modules rather than just modules name like you would maybe with loading a module, a model. So this is the syntax. Import some functions or classes from this module name, which is almost like the path name to the file. And what it allows you to do, let's say I want to use spawn box. Instead of saying spawn cube here, no, I'm just going to add some more things to the scene. So let's say that I want to have a primitive box in the scene. So I say box 1, if I have to put let or constants in before it, box 1 equals spawn box. I don't know how that E got in there. Anyway, spawn box. And then I put 9 parameters in. X, Y, Z of where I want it to be. And let's say 3, 1, 3. So it's closer to the southwest corner. And I often just kind of give myself a little extra space before the next 3, which are, and do you see how the parameters are being suggested to you on the pop-up? So X, Y, Z are the positions. The rotation in X, Y, Z, I'm not going to rotate it at all initially. And the size, X, Y, Z or scale, which again, I'm going to say unchanged. Just the normal default size for a box shape. That line does all the work that all those other lines above does. And it also gives me the ability to find the rotation and size. It also adds it to the engine. So it does the whole darn thing.
Hey, Carl, quick question.
Yeah.
Are we able to use variables? Can we pass in variables here to the spawn box function instead of
Yes.
Static numbers?
Yep, absolutely. You can put this thing in a loop and line a bunch of things up in a row.
And so we can randomize a variable with different values and pass that into spawn box. Okay, very cool.
You bet. Yeah, this can be a variable. It can be a mathematical random function. It can be anything. Tell me why I have a syntax error here. See the red?
2 names, 2 exact names. Just need to rename The first one
Yeah.
or the second one?
It's the problem with it. I'm redeclaring the same name, so this would be box 2.
How come it doesn't just overwrite the value, like, or this, it would only use whatever you assigned it the second time?
Because I put the word let in front of it. If I hadn't, it would have done just what you said and been fine. No
Okay.
complaint. It's just this box just got abandoned and it actually never shows up and it just goes away. Actually, that's not quite true in this case because I've added it to the engine. The engine will hold on to it unless you remove it for the engine. So you could, in a loop, use the same variable name again and again, but you wouldn't be able to use that name later to get a hold of a particular copy of the box. It's graying these things out because I'm not using them down below anywhere. I'm not referring to them. But if I wanted to, move it later or do something with it, I would use this variable name. I didn't import all of the methods from the spawner module. If I right click on this and say go to definition, it'll actually open up that other file and you get to see the whole thing. It's rather long because it spawns all kinds of things, entities, boxes. With the X on the end, the extra X on each of these, it says it's the extended version. It gives you all 9 parameters. Without that extra X, you just get the position and the default rotation size. So it does cones, it does cylinders, it does GLTFs, it does planes, spheres, and text. There's a text object.
Is there a similar file that you're able to pull up to show all of the properties of the transform class? So, we can rotate, we can scale. Can we see, like, is there a, like,
I would say, I think what you're looking for, what you're asking for is, we had it in one of the examples, to have I closed that one, where the, it had all 3 of the properties for the rotator. Oh, yeah. Go to export any builder scene, and there it is, right there. There's your 3 sets of values. It is just that. It's just the transform. You can omit any one of these, any 2 of them. You can omit all of them. But if you include them, then you're specifying the position or the rotation or the scale of this transform.
I guess I was looking for like a fade property, like where you can fade in and out an object, and also maybe like where it dies, like it disappears, like a hide.
The things you're describing there are not transforms. The fading is a material property to make it more and more transparent. The die, like just take it out of the scene completely, would be to one way you can do it is make it 0 size, but the other way you can do it is to remove it from the engine, say engine.remove entity. There's a bug with remove entity right now that they have to fix, that when you remove an entity, it may cause one of the other entities to go berserk and like go to 0, 0 and get really big, or just lose its transform, I guess is the best way to say it. So it goes to 0, 0 and goes to default size and rotation. I don't know if they've fixed that. They've done a whole bunch of fixes since last time I tested it, so they may have fixed it. But be suspicious that if you remove something, remove an entity from the engine and something else goes weird in your scene, that's probably why.
I saw a piece of code earlier today where you were changing the color of the object directly, like to blue.
Yeah.
And that wasn't a material. Are the colors able to be?
Oh yes, it was.
Now using code.
No, it was. I'm sorry. If we're talking about a primitive object, by primitive I mean not a GLTF or GLB shape, but a box shape or a cone shape or a sphere. So a primitive object, you define the materials in code using the material or basic material types, components. And once you've created a material, I'm not familiar with the basic material. I just use the material one. One of the properties of a material is its albedo color. So if you had a material called M, you'd say M equals, let M equals new material, then you say M dot albedo capital C color equals, and then you have to provide the numerical value of blue, and there's ways of doing that with text, like color 3 dot blue or something like that. If you find it in code, you'll find it in examples of primitive shapes being set to colors.
Right, and so that's not a property of the transform class, but
Correct.
What
it's
is
a
it?
property of the material, material object. Material, okay. So when you create an entity, you add a shape to it, you add a transform to it, and you, if it is a primitive, you add a material to it. Those are all components, and components have properties.
Okay, and so my question, just to wrap this up here, is there a way to find out all of the things that are available that you can change on a material? So you can change the color. Can you change like the fading in and out of that color and other things about the material? Is there like
if you want to fade something or shrink it or make it go transparent, you do that using an update method over time. You keep changing the transparency or changing the color. It's
okay.
not a property you can put into the material that causes it to just sit there and change.
Mm-hmm.
Okay?
Very good.
You have to code it. To find out all the values that are available, you can go into docs.decentraland.org and go to the section called it's the basic reference section, and there's a page in there called materials, and they are listed. The lists and coding is different for basic materials and just materials. But another way you can find out is, I'll show you quickly. The box in the init scene does not have material added to it. So I'm going to add a material to every cube. It'll be all the same material for each cube, just to make it simple to demonstrate that you can use this on the editor itself to do that. So you can say const m, material, can be any, this is the variable name, anything you want, equals new material. And then you say material dot, what you got? Here they are. So all the things you can, the little blue boxes are properties, which means you can go like, one of them was albedo color. Albedo. I have no idea what albedo means. Does it have something to do with old style painting, maybe? Classical painting descriptions. It's showing me a syntax here because I need to put something on the right side here. If I can use pound and 4 hex digits. Sorry. Not 4. 1, 2, 3, 4, 5, 6. What's wrong here? It defaults to. I don't hardly ever do that. So what I really would
quotes maybe
call it quotes. It's a number. I wouldn't think so. It's saying to use a pound. 6 digits. What I'm going to do instead is go color 3 dot, and there's the colors. Color is like a number with 3 parts in it. The first part of it is the red part, the second part's the blue value, and the third part's the green RGB, red, green, blue. But color 3 is a class that has methods on it that return the numerical value you want for that color. So if you say blue, parentheses, a quote, it's a method on the class color 3. So you have to call it like a function. And this says now that I have a blue material, but I haven't applied it to the box yet. So I say cube.add component of material.
Is blue a method because you can actually put in a number to specify the shade of blue that you want?
Yes. No, not in the blue function, but in an alternate syntax to color 3. What you could do is, instead of this, that works. But you could also probably do this. Can you do a vector 3 of 0, 0, 0? Color 3 of it is a class. It has methods on it, but if you want an instance of a color, you've got to do that. So now these are the RGB values that go from 0 to, I think in this mode they go 0 to 1. So I want it to be blue. I'd go 0 RGB 1. Be a bright blue. I've added a component of the material so that all these boxes now should be blue. Let's try it out. Always forget that first click doesn't create a box. So they're blue. Also looks like they, by default, they're a little shiny. Material. There was no material before, and it was matte. But I think with a little bit of material, you get a little bit of shininess. And going back to our code here, cyan is a combination of green and blue. So saturated green and saturated blue. There it is.
Would we use decimals to change the shading? Like
Yes.
like a 1.1 for blue or a 0.9?
I apply less green. It'll be a darker blue green. I use 0.5 here. Right here.
This is really cool because I'm assuming you can use variables in this manner too then to
Sure.
change the shading.
Mm-hmm.
Kind of,
Yes.
I like this numerical approach rather than the, what do you call it? The hex or the,
Yes.
the hash.
Yes. Yeah, because that's you can't
You have to
control that
hard-code it,
with algorithm, right? Mm-hmm. If you just want to make it quick blue and you don't care about the fine details, you can of course use this form, which is a class method on the color 3 class, as opposed to creating an instance of a color. I mean, it's just, this returns an instance of a color. This will work also. Yeah, I could be incrementing the, changing the colors a little bit on each click of a box, right? Here's the blue. I was showing this how to use the spawner functions. I'm going to go back and finish that, and then we'll wrap. Yes, cube. See, that was a box. Let's go cone 1 equals spawn cone x. And oh, I'm lazy. And let's just move this 5, 5. Now it's complaining here a little bit because it doesn't know spawn cone x, because when I did the import up here, I didn't mention it. It happens to exist in there, and it's fine now. And to do a GLTF, you got to do 2 steps. So you got to say let what shape did we have? Shiny state. Be customary to have variables start with lowercase and classes start with the uppercase, but to use what's called camel case, the capitals in the middle to kind of break up the words. You can use underbars. You cannot use minuses because it looks like I'm doing a subtraction. Equals new GLTF shape of, and then we had, let's just go put those models from that other scene. I'm going to be lazy and do the whole thing. Where was that? Color? No. Where was our scene that had the shiny thing in it? Maybe we put it shiny red. There it is. I'm just going to grab the models from here and go back a couple. Here. Bringing the entire models directory over. And it has a rock. It has the shiny thing. I'm just going to use the shiny thing in the models directory. Okay, so you go quote models, and here you do not put / first. This can be either double or single quotes, /. You need to first bring the shape in, and then you do let shiny equals new, spawn G LTF X. I'll use the full form of it, and once again you have all 9 parameters you can use, and but this one requires you first to pass in one more parameter, which is the shape. Pretty easy way to get a shape in and placed and rotated and sized, huh? So this spawner module is pretty convenient, and you have to list up here any of the methods you use from it. If you list one that you don't use, it gets grayed out. If you use one that you don't list up here, it gives you a syntax error. Let's just see how this looks. This is scene 7. Using the spawner function just saves you lots of time and makes your code a lot more compact, easier to read. You're not writing lots and lots of code for the stuff that really you just want to do once. And why isn't the cone rotating? It's a trick question. It is, of course, rotating. You just can't tell. Maybe you can see the segmentation a little bit along the bottom. Rotating, yeah. Yeah. It's not perfectly round. It's little segments, and it is rotating. Okay. So there you see the use of the spawner function. There. I will rezip. I will clean up these folders. I'll zip them back up and reattach them to the class chat and the document. Sparking a fire, huh? That's good. All right. I'm very pleased to be doing this course and very glad to have so many people interested, and have fun. Let me see what you can do in your assignments.
Thank you. See you next week.
All right.
Thanks a lot, Carl. Great.
You're
Thank you.
really welcome.
Thank you. Thank you. See you next time.
Thanks, Carl.
Bye-bye.